Okay, in this video, we're going to talk about rack and pinions. So, rack and pinions is very similar to other gears, except one of the gears is unraveled into something that's linear, and the linear part is what we call a rack. And then the pinion is the part that's usually driven by a motor. So, like we spec'd out the other ones, we typically have a gear pitch that we look at that we have to make sure it lines up. And then in terms of material selection, everything else is pretty much the same. And in terms of the rack shape, you have rectangular or round. So those are some different types you might deal with. And if you're working with metric, you'll be looking at the module parameter. Okay, so let's take a look at some. So let's see, let's take a look at the racks first. So if we scroll down, let's look at an inch one. So you could see that they tell you the length and then some of the height and face width dimensions. And you have stainless steel, carbon steel. These aren't hardened. You could get hardened ones down here if you want the teeth to be harder for stronger applications. But for this, we don't really care. We're just going to show how you put it inside an assembly and work with it. So let's see. We have this one's a gear pitch of 64. So we could go ahead and play with that one. I will open up that in another tab. And we'll see if there's another one for the gear corresponding to that. So you can see these here correspond to 64. So we'll open this one up. This one specifically has 36 teeth. And you can see this one here, they don't tell you. But as long as the pitch lines up, it should be fine. So we'll go ahead and download this. And we'll put it in our rack and pinion folder. So as the name suggests and how this looks like, this is usually to convert rotary to linear motion. This is why one of the gears is straight. So we'll see it in action when we put it in the assembly. So if we open up the rack, it's going to look like this. You can see the tiny teeth here, and this is linear. And then for the other parts, we can open up our gear. Okay, so this gear here has a set screw to hold onto a shaft. So that's how this one works. But I could go ahead and make an assembly. So we'll put the rack here and then our gear. So if we do a rough check, we could see how the gear teeth lines up. So at a glance, it looks pretty good. And I could mate this to this surface. Okay. And we can see that the gap between the teeth looks pretty good. If we zoom in, you can see that this is what we want. So the next part is to figure out the actual distance. So let's take a look at the specs here. So we have gear pitch of 64. And let's take a look at let's see. We could This one has a gear pitch height, and then this one has a pitch diameter of 0.563. So you typically want the pitch diameters to line up, but in this case it's a pitch height, so the two lines should intersect. So if we're looking at the assembly here, the center of this the perimeter of that should line up to the pitch height. So we could go ahead and there's a couple ways to do it. But for now, let's first add an axis. Okay, so we have an axis here. And then let's go ahead and create a plane that is 0.464 away. And we will just flip the offset so it's in the other direction. And you can see that plane is somewhere in the middle of the teeth. So the distance from that should be 0.563 divided by 2. So if we take this and the other plane and we mate it, we should have a distance mate of 0.563 divided by 2. And if we go normal to it, you should see that it's pretty much where it should be. Okay. But notice that right now the gear is still pretty much free to move. It has a rotation. So we need to figure out the correct spacing for this. So let's see if the specs mention any ratio. So we're looking at this one here. Okay, so we could probably do a 1-to-1 for this. But let's see. Okay, so let's actually take a look at the options we have. So if we go to mate and mechanical, we can see there's a gear option. And under rack and pinion, it says pinion pitch diameter. Okay, so we probably want to find the right pitch diameter. So we saw it was 0.563, right? So if we go ahead and make a sketch here, we could sketch one that's going to be 0.563. And we could hit OK. Now, if we come back to the mates again, so our mechanical mates, and then rack and pinion, pitch diameter. Let's see. Okay, so this rack, we should click an edge. And there you go. So if I drag this, you can see that it's moving accordingly. But right now, one thing to note is that I have the pinion moving, but in practice, you could have, or more commonly, you'll see the pinion fixed and the rack moving. But at least relatively, you could see that the teeth engagement is as we expect. Okay, so normally the rack, if it's moving, you could have some different objects attached to the rack. So you could, depending on what mechanism you're trying to drive, that part could change. And then for this, you could have a motor attached, and the motor could be fixed, attached to something. It just depends on how you want to do it. So I won't show it in that video, but at least you could see how the mates assembly works for a rack and pinion here. Okay, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one.